Namaste. Today we are going to design a sewer line, especially circular sewer line for given locality. Um, Suppose we are going to take Hetona 17 Mokanpur. For the given locality, population is present population is 6,860, and rate of water supply for given locality is Q equals to 109 LPCD. As the sewer line almost contains most of the water which is from the water supply, that's why sewer supply means mostly the water supply 109 liter per capita per day, and Manning's coefficient n equals to 0.009 for PVC pipe. Average slope is taken as 1 in 200. Peak factor is taken as 3. Flow depth ratio small d by capital D equals to 0.5, as we are considering the maximum flow as half full running condition. For a half full running condition, depth of flow d small d equals to diameter by 2. हाफ फुल कन्डिसनको लागि चाहिँ डायमिटर बाई 2 हुन्छ हैन. वेटेड पेरिमिटर p इक्वल्स टु पाई बाई d डिभाइडेड बाई 2. एरिया अफ फ्लो सेक्सन a equals to pi d square by 2, that means pi d square by 8. Weighted perimeter means the whole perimeter of the circular pipe is pi d, and that's why for a half full condition weighted perimeter is pi by 2. And area of flow section for this half full condition, the area of circle divided by 2, that is a equals to pi d square by 8. Then hydraulic mean depth, that is r equals to area divided by perimeter, that comes to be d by 2. And the velocity of flow is given by Manning's formula. V equals to 1 upon n r to the power 2 by 3 s to the power 1 by 2. Calculating velocity, as we get v equals to 3.117 d to the power 2 by 3. What is the motivation behind the sewer design is we calculate velocity and discharge and the discharge is compared with the discharge of rate of sewer supply, and from where we calculate the diameter of the pipe. Now discharge Q equals to AB, Q equals to 1.224 d to the power 8 by 3. Also the discharge equals to rate of sewer supply, that is rate of water supply times population, that comes to be 0.00865 meter cube. Equating equation A and equation B, we get 1.224 times d to the power 8 by 3 equals to 0.00865, from where d comes to be 0.156 meter, that is diameter of the pipe is 160 mm, that is 16 centimeter. Then check the velocity for this diameter. V equals to from equation above equation, V equals to what? V equals to 3.1777. From here 3.117 d to the power 2 by 3 Now diameter diameter comes to be 0.156. Suppose take it as 160 mm, then velocity v equals to 3.117 d to the power 2 by 3, that means 3.117 times 0.16 to the power 2 by 3, that is 0.92 meter per second. This is the half full running condition, that is maximum flow or half full running condition. The velocity of flow is 0.92 meter per second, which is greater than self-cleansing velocity of sewer lines, that is 0.6 meter per second. That's why it is okay. The diameter of the sewer line, the diameter of PVC pipe is taken as 16 centimeter, and which gives the velocity of flow as 0.92 meter per second for given discharge of sewage. And then for we are going to see again for next condition, as the sewer line always does not contain the half full running condition, sewage can flow on minimum and maximum flow condition. For next case where the flow is less than half full running condition, suppose velocity of flow sorry depth of flow is less than half full condition, depth of flow is less than half full condition, and the flow subtend angle theta on the center of the pipe, then the cos theta by 2 equals to OC by OA, OC by OA, then cos theta by 2 equals to what? 2 times 1 minus d by 2. Here we have already found that the diameter of pipe is 160 mm. Then the depth of flow small d equals to, from this depth of flow d equals to d times 1 minus cos theta by 2 divided by 2 weighted perimeter. Similarly, this area weighted perimeter is pi d times theta by 360. The whole perimeter of the pipe is pi d, circular pipe is pi d, and only the where the depth of flow is d, and the depth of flow subtend angle theta in the center. That's why weighted perimeter is pi d times theta by 360. Then after area flow section, similarly for area flow section, a equals to what? A equals to, here a equals to what? First of all, we calculate, to calculate the area flow section, we have to calculate this area, this shaded area OAB. This shaded area, we calculate the area of this shaded area. This area is calculated. The area of that section is what? The area of that section is pi d square by 4 times theta by 360 minus, and this minus this triangle OAB, this triangle OAB is subtracted, then the area flow section is obtained. Hydraulic mean depth, that is R equals to area by perimeter, and velocity of flow is what? Velocity of flow is similarly obtained as earlier. Then after depth of flow d by 3, suppose minimum depth of flow d by 3, weighted perimeter similarly calculated, area of flow section this calculated, this is area of the whole circular section for depth d, and minus area of this triangle OAB. Hydraulic mean depth similarly calculated, velocity of flow. Now velocity of flow comes to be from calculation. Velocity of flow comes to be what? 1.15 meter per second. Velocity of flow is 1.15 meter per second, which is greater than 0.6 meter per second. That is why for minimum flow condition, the velocity is also greater than self-cleansing velocity. Hence, the given diameter of pipe is okay. And in this way, we design the diameter of pipe, for given sewer line for given locality. Here diameter of pipe for given locality for the sewer line comes to be 0.16 meter, that is 16 centimeter or 160 mm. This is the diameter of the pipe for given discharge of sewer for given locality. Okay, thank you. If you understood, if you really understood and like the content, then like the content, like, subscribe and comment for this content. Thank you.